Hi, Dr. Precht, can you hear us?
I can hear you now.
Oh, perfect. Uh,
If you notice, I'm sitting in my car right now.
yeah, I see that.
I'm actually at a meeting called the Reef Florida meeting, and
Oh,
it's at
cool.
the Frost Museum of Science down here in Miami, and it's a meeting all about reefs in Florida.
Awesome. Well, we're really excited to have you. I'm Jason Holmstrom. I'm the guy you've been corresponding with here at in Atlantic City, New Jersey, at the
Awesome.
Dr. Luther King Jr. School. We have today a few members from our Lego Robotics team, and
Okay.
we have some questions that we wanted to ask. Before we start asking them, though, I'd like the group to go around and introduce themselves. So
That
there's
would
a
be wonderful.
flag in the camera, so it might take us a minute, but we have about 5 people here that want to introduce themselves. Kendriel, would you like to start?
Sounds great.
Hi.
Thank you.
Hi, Dr. Preck.
Yeah, keep talking.
Okay. Hi, Dr. Preck. My name is Kendra Salvador Noel Guzman.
There's Kendriel. Christian, you want to go next? Okay, go ahead.
Hello, Dr. Preck. My name is Xander Cohn. I'm in the 6th grade.
Harmony?
Nice meeting you.
Nice meeting you too.
Hello, Dr. Precht. My name is Harmony Emerson, and I am in the 6th grade.
Nice meeting you.
Hello, Dr. Precht. My name is Madison Gates, and I'm in the 7th grade.
Christian?
Did you say your name was Madison?
Yes.
Madison, yeah.
It's my name.
I'm sorry, whose name? Well, you kind of cut out.
I said that is my youngest daughter's name.
Oh, cool.
That's awesome.
Hello,
Yeah.
Dr. Precht. My name is Christian,
Yeah.
and I'm in 6th grade.
So those are our
Nice
students.
meeting you.
Thank you.
I might have mentioned in a prior email that we're part of the Lego Robotics team. This year's theme is submerged. So part of the competition is you have to explore an underwater problem and then try to come up with innovative solutions to it. And we, through the research, had come across this disease known as the stony coral tissue loss disease. And we wanted to know more about it. So we have a series of questions. Actually, Kendriel is going to ask the first question. So Kendriel, did you want to start?
Thank you for taking the time to meet us, Dr. Preck. From our research, we discovered that you were the first worksite student with the New York State Department of Parks and Recreation. How did you ultimately end up at the University of Miami to study coral reefs?
So that's a great question, and it has to do with my background. So I grew up in New York City. I grew up in Queens County, and I went to a New York City public high school. And when I graduated, I went to the State University of New York at Oswego. And when I was a student at State University of New York at Oswego, which is in upstate New York on Lake Ontario, I majored in geology with a minor in biology and a concentration in marine science. But I was also a hockey player, and I happened to get injured in my senior year, and I didn't want to stay in school at the time because I was very frustrated with my injury. And the university at the time had a study abroad program, and they offered a program to go to the Jamaica, Caribbean, and see coral reefs for the semester. And it was senior year of college, and I was a scuba diver. I had learned to scuba dive with my dad when I was in high school, and I saw this opportunity to basically study something I was studying in school using my scuba diving experience and kind of getting away from the hockey team at the time, which was good for my head. And I went down to Jamaica, and I remember it like it was yesterday. I did a dive, a checkout dive, the first week we're there, and I got back to the boat after my dive, And I said to my advisor, who was one of the professors on the trip with us, I said, how can I do this for the rest of my life? And basically the next thing I know, I'm going to graduate school at the University of Miami. And then after that, working as a coral reef scientist for my entire career. And I've been doing that for about 40 years now.
Thank you. Tanner, did you want to take follow? Here, so, number 2.
How does a typical day in your field look like for you nowadays?
Well, nowadays, because we've had a lot of bad weather lately, I've been sitting at a desk or going to meetings or making phone calls and trying to keep my clients. I have a bunch of clients that we do projects for, and so I'm a consultant in the marine science field, doing a lot of coral reef work. And one of the projects I'm working on right now is a telecommunications cable company are laying fiber optic cables in the ocean, and where the cables come to shore.
Yusuf Young, please report for dismissal. Yusuf Young, please report for dismissal.
Sorry, we had an announcement there.
Could you repeat that?
That's
Yeah,
fine, no problem.
We heard the
so-
part about the
Yeah, sure. So
telecommunication.
so there are these companies like AT&T that lay fiber optic cables in the ocean, and where they come ashore is in a place just up the road from us here in Miami, in a town called Hollywood, Florida, which is by Fort Lauderdale. And basically where the fiber optic cable, which is a small cable, it's only about 8 inches or 12 inches or so in diameter, but where that cable crosses the coral reef, they have to permit that. So with the environmental groups, state agencies, etc. So my company and myself, what we go out to live, and we basically evaluate the area where they lay the cable, and we tell them that this is the community, there's species, and these are the ones you need to avoid. And then when they lay the cable, if there's any injury to those resources, if there's any damage to those corals or anything like that, we go out there and we try to repair those injuries. So like if a coral is dislodged, we cement it back to the reef. And that's a typical day in my world. So right now we're doing this assessment of this corridor, underwater corridor, of where they plan on laying these cables. And I have a team of three in myself, and we're diving. If the weather holds, we have 35 days of field work, of underwater work, that we have to pull still remaining to complete the project. So I'll be underwater probably half the days from now through Christmas. That's a typical day in my world.
Not bad.
Not bad, yeah.
Okay.
In your scientific reports article, you examined the white plague disease. In the eco article, you explore stony coral lost tissue disease. Are these diseases related?
They are the same, basically. So what happened was, there was a disease known as white plague disease, and it was commonly found throughout the Caribbean. And in 2014, off of Miami, there was a disease that broke out that resembled white plague disease. So at the time, everybody who saw it, including myself and my team, we called it white plague disease. And then after following the disease underwater and taking photographs of it and looking at its rate of spread and so on, we basically noted that it was more virulent. It had higher strength, and it progressed faster, and it killed more corals than typical white plague disease. And what that led some people to do was say, hey, it might be a different disease. So they called it stony coral tissue loss disease to differentiate it from what we originally called stony coral tissue loss. White plague disease. same thing. Because in human terms, it's like COVID. So COVID, when it first came out, it was COVID, and it is COVID-19. And after a while, there were these variants that started coming through, and some variants were worse than the earlier disease, and some weren't as bad. Some were more contagious, some were less contagious. And we're still dealing with COVID variants. And every year we deal with flu variants. And it's pretty much the same thing. So stony coral tissue loss disease is a more virulent, more contagious, with higher levels of mortality disease than original white plague. So it's like an extremely bad case of COVID for corals, if you think about it that way. Does that make sense?
Yeah.
Absolutely. It's like the big bad cousin of white plague.
Are y'all still doing
So-
research about the white plague?
We are, and I'm working with a whole bunch of folks from different universities, and it's really interesting because in some cases, when you take tissue samples from corals and you do analyses of the different bacteria that live on it and the different viruses that live on the coral, you might find one that is out of the ordinary, and that one is known to be pathogenic to corals. In this situation, we still haven't found, quote unquote, the smoking gun. We don't know what the exact origin of stony coral tissue loss disease is. And in many cases, don't know what the origin of what it is. Now, there have been outbreaks that we can relate to wastewater treatment or to water quality. But in this case, the event that happened that's now known as stony coral tissue loss disease that started in 2014 off of Miami and has now spread throughout the Caribbean, we still don't know the causative agent, the thing that was responsible for starting it. There's speculation, but there's no hard science yet to definitively say what it is.
Do you believe in any of the speculation theories? Such as
Well, yeah, go ahead. Go ahead.
such as the theory that different water was brought in through water bearing ships that has brought in different bacteria.
Right. So that idea is known as the ballast water hypothesis. And the thing about that hypothesis, I mean, there have been studies that show that if you take water, the ballast water from a ship, and you inoculate it with stony coral tissue loss disease water, and you put it back in the ballast of a ship, and you take that water out a month later, the disease, in whatever form it is still active. So if you think about that, so if you pick up water in a port somewhere like Port of Miami, and there's disease water, and you pick it up into your ship hold, go to the Bahamas, and now you let your ballast water out in the Bahamas, all of that water that you just let out of your ship was infected from water in Miami. And there's the idea that it could spread from port to port, island to island in the Caribbean by that means. And while that's a very logical hypothesis, the spread of the disease hasn't necessarily followed shipping lanes or shipping patterns. It's been a little more difficult than that. So the easy answer would be, oh yeah, it's spread by ships and their ballast water. And while that's still a possibility and still could happen, the likelihood of its origin and its spread, especially through Florida, is not related to ballast water. For instance, in Florida, the disease started in fall of 2014 near Miami, and you could almost time the movement of the disease from reef to reef to reef to reef to reef over the next few years in the state of Florida. So it moved both north and south from its point of origin, and none of that had to do with ships. It just had to do with water currents. So it's a waterborne pathogen. We know that. But again, that doesn't mean that ballast water can't transmit it. But the original spread of the disease through Florida was just related to water currents, the ocean currents.
What is the role of bacteria in coral diseases? Is it the cause of the disease? Or does it make it
So that's
worse?
that's a great question. So the bacteria, one of the hypotheses is that the disease is bacterial in origin, and its lethality is related to the bacteria as well. And one of the reasons why we know that bacteria are involved in the disease is if we treat corals with antibiotics, they actually heal and they get better. Just like if a person has a bacterial infection and we give them amoxicillin or whatever antibiotic, they get better from those treatments. The same thing with corals. So there are actual amoxicillin pastes, almost like toothpaste, and scuba divers take those pastes that have amoxicillin medicine in it and they spread it on the coral, on the disease, and it actually abates, or it puts to rest that disease on that coral. So that's one of the reasons why we know that it's probably bacterial in origin. Another thing that they've done in some experimental treatments in some laboratories is they'll put healthy corals in an aquarium. So they have a fish tank basically that has some healthy corals in it. And then what they do is they take diseased corals and diseased coral water and they add it to the tank and they see what happens. And sure enough, the corals in the tank get infected. So then they do the same experiment in another tank right next to it. But in that tank, before they put the diseased coral and diseased water in those tanks, they treat the water, pre-treat the water with antibiotics. So they pre-treat the water with amoxicillin, and then they put the disease in there, and sure enough, the corals don't get the disease after they've been treated. So that's another reason to think that the origin of the disease is bacterial, and it's the lethality of the disease is related to bacteria as well. The only thing is we don't know which specific bacteria are related at this point. We know that there's a consortium of bacteria, a whole group of different bacterial species that may be involved, but again, we haven't found the one or two individual bacteria that could be the causative agent for this. And that would help us immensely if we knew that. It would help us in our treatment, because then we could design treatments specifically for that bacteria or that disease.
I was actually going to ask you a question about global warming and things like that, but I think I kind of would like us to stay on this treatment that you're talking about, because that is something that we found. We found a video where Samantha Burgess in the Bay Islands of Honduras, she's a research coordinator that was doing everything that you just explained with the application of the amoxicillin and things like that. I guess one of the questions, actually, we're going to skip to question 8. That's your question. Can you ask? We're going to go back to that too.
And by the way, I will answer your global climate change question because I sort of know what you want to ask. And there is a link, and I'll talk about it later.
Actually, that sounds good. Actually, Madison, why don't you go with yours? Because Dr. Precht did talk a little bit about the antibiotic, but maybe there's more. So ask number 7.
What type of treatment is being used on coral reefs infected with SCTLD?
Okay, so there's a couple things. The first thing that people thought was there were some coral species that were very susceptible to the disease. So basically, one of the first things that people thought about doing was if they saw a coral get disease, they'd remove it. So they just take it off the reef. They take it, they'd see a diseased coral, and they'd take a hammer and they'd break that coral off and they'd bring it on to land and remove it from the ocean so it wouldn't spread to other corals. And that's called culling, C-U-L-L-I-G. And that was one of the things that people started doing early on. But what they found was it really wasn't slowing the progression of the disease much. So it wasn't working. And that's when people started to play around with testing different antibiotics and different treatments like that. And the one that seemed to work the best was amoxicillin, that medicine, which is it is an antibiotic, and they would mix the drug, the powdered drug, into like a paste, just almost like I said, like a toothpaste. And they would then take that paste and by hand spread it on the infection on the coral, and sure enough, the coral would heal, or the disease would stop spreading. And that basically was like, well, that's a good sign. The only problem with that is if you think about like how many millions of corals there are on a reef, if you take a diver and you put him or her in the water, and you have them treat individual corals by hand, how many divers would you need, and how much amoxicillin paste would you need to treat all the corals in an area? And it almost gets to a point where it's impossible to scale it up at the level that you need to do that. So think about, again, like back in the day with COVID, just a couple of years ago, when the disease first started out, there was no treatment to the disease. So when the disease started, it was killing people, especially in the New York, New Jersey area. And then within about a year, they developed vaccines, and they also developed some treatment drugs. One of them is Paxlovid, that you could actually, if you get sick from COVID, and if you take the pill early, you actually don't get as sick as you would get if you didn't. And that's similar to where we are with this coral disease. So we have some idea. In this case, with the coral, it's bacterial. It's not viral in origin. And the question is now, how can we scale up this treatment of antibiotics of the corals where it's more than just a few divers hand treating corals, but are there ways where we can develop a treatment that has broad scale application? And I was actually thinking, when you guys were originally talking about your project, one of the things that might be something to consider is, how do you scale up with underwater robotics or some sort of technique? How can you scale up delivery of antibiotics to corals that need treatment, and do that without having to rely on scuba divers to do that? So that's something to think about, maybe for a cure plan of how we can go after this disease at a larger scale where we can actually make a difference.
Yeah, I mean, when you're talking about scaling, that's the first thing that we were thinking about too, is like scaling through technology, using technology to automate a process or something like that.
Exactly.
Kind of leads us into number 8, because you were going to ask a question about the technology.
What technology do you use to treat your present infections?
I'm sorry, I repeat the question slowly.
What technology do you use to treat the present infections?
Okay, so like I said, most of what we're doing right now is scuba divers going in the water and diving down on the reef, and they carry with them this putty, this paste, and they take their gloved hand and they treat the corals by hand. So on a 1 hour dive, an underwater dive, one diver may be able to treat maybe a couple dozen small corals and maybe a half a dozen large corals, and that's the number of corals they can treat. But on that reef at that time, there may be hundreds or thousands or even more corals that are infected. So again, that's the methodology that we're using right now, and it's very manpower intensive. It's scuba diver intensive. It's how many people you can get in your boat, how many people you can get on the reef in any given day. And if you can automate that process, that would be cool, right? Now, I will say this about antibiotics is in some treatments, and you probably heard this with human treatments of antibiotics, that there's resistance, drug resistance. So we also don't want to just willy-nilly dispose and treat everything out there with antibiotics, because in some cases they may have negative long-term impacts. But I think the way to go about this would be to find a technology that could deliver these doses of antibiotics to corals that need treatment, that don't need individual divers to do it.
So we would like to explain one of the things that we had come up with. It's not quite scaling to the point that you're talking about by circumventing the diving. Like, it still would be a diving tool, and we don't really have a complete prototype worked up. But
I mean, we can make a robot.
Right.
Does that,
yeah.
You know, that's.
But Xander was gonna explain kind of what we were thinking, the process that we were thinking. Can you
So, I mean, this is all we have, unless we have bridges.
get out of here? Okay, sorry, we're having Zoom difficulties. Apparently our meeting has to end in 10 minutes, or we gotta like pay for a full Zoom or something. But
Okay, we'll do this for the next 10 minutes, and then we'll set up another day and we'll do it again.
that sounds great.
Thank you.
So Xander, do you want to explain to Dr. Precht the basic concept of the thing that we're gonna use to spread the antibiotic?
So we would take a prototype, kind of like a caulk gun, as an example,
Exactly.
and we would take something automatic. So I'm just gonna use this massager,
Yeah,
and where we would have to press the button, and then it just squirted itself. Where it just squirts it itself, and then all we really gotta do is dive down there to put it on there. But my idea is to have like a silicone as the shape of the coral. So all we gotta do is squirt. It just comes out as the shape that the coral is, and we can have different types of shapes depending on the type of shape of the coral.
so we have the caulk unloaded with antibiotic with a special nozzle that will direct the stream of the paste into that, something similar to a massage gun, like an oscillating finger, because we noticed in the dive video that the divers were just using their finger, almost like you would caulk a bathroom tub or something.
That's exactly right. That's exactly right.
That liminal space between infection and non-infected coral.
That's right.
So
Exactly.
we were talking about even perhaps 3D printing a better tip for the massage gun that wouldn't harm the coral. Now, I mean, I guess all we're doing is basically automating a process that's already been done, the hopes of making it faster. So I didn't know if you had any thoughts.
If you could, let's say on any given day, like I said, a diver on one dive can do so many corals. If you can double or triple their success every day, right? And you do that with multiple divers every day for months, all of a sudden, instead of treating 100 corals, you're treating 300 corals, or instead of treating 3,000 corals, you're now treating 9,000 corals. So however many divers you get out there that can use this automated process, if you're tripling the delivery, then you're tripling your impact. And that's tremendous in something like this.
And you also don't have to reach as far, like how you'd have to get close up to it. You don't really have to.
Exactly.
Far.
We also, and I know our time is running out, I'm afraid it's gonna like shut off on us, but Harmony had also, if we do another meeting, I really would like her to talk about, well, actually, why don't we try to squeeze in your thoughts?
Yes,
We were
please.
Also at a monitoring aspect of it.
Yep.
So, Harmony, did you want to talk about your thing?
What technology do you use to monitor and assess coral reefs for disease? For example, a robotic fish, how useful could that be for finding stony coral tissue loss disease?
So basically, the fastest and best way to monitor coral reefs now and gives you a permanent record is you take 2 GoPro underwater cameras and you basically attach them to a pole and you swim over the reef with the video on, and you swim an area that you want to survey, and you basically then make a mosaic, which is basically a photograph that basically stitches all of those video frames together and basically gives you like an underwater photographic map of the area. You could see all the corals. You could see which corals were diseased, which corals weren't, which corals were treated. And what you do is you do that same place every few weeks or every few months, and then you basically compare them, and you can, just sitting at your desk with your computer, you can evaluate, oh, look, this is where we treated the corals, this worked or didn't work, and these are the reefs we didn't treat, and look at what happened there. And that's the way we go about monitoring, and that has become the new, basically, standard for coral reef monitoring. The only thing is, to do that, you need a special software that is actually freeware. It's Agisoft, but it takes a lot of computer power. So you need a strong computer to do those underwater mosaics. But that's the methodology and the technology that's available, and it's the best and gives you the most information for the best bang for.
What was the name?
Yes.
Is it cutting out?
Yeah. Oh,
Okay,
Bill, you still there?
you still there?
I'm still here, but I
I
heard.
was cutting out on his.
Yeah, I'm still here.
I did want to ask real quick though, what was the name of the software that you mentioned?
It's called Agisoft, I believe.
Agisoft.
Agisoft.
Okay,
But I can text you and email you because I have your phone number and email now, so we can communicate that way easily. Okay?
yes.
And any questions that anybody has, they can ask me in a written form, and I'll respond. I'll do whatever I can to help you guys out.
I cannot thank you enough. We cannot thank you enough. We really appreciate your time. We've been excited to talk with you. Thank you so much for sending the articles. They really helped prepare us today.
By the
and
let me interrupt for a second.
Sure.
There's a woman at the meeting that I'm here today. Her name is Karen Neely, Neeley, and she's written a lot of the papers on amoxicilla treatments of coral for stony coral tissue loss disease. And she just gave a talk that I just came from on amoxicilla treatments on stony coral tissue loss disease. So I come here primed for this presentation.
Yeah, that's cool.
That's awesome.
So I will reach out to you via email or text, and maybe we could set up another meeting. I mean, I don't want to take up too much of your time, but we really appreciate it.
The thing that was in the way is, like I said, I've been diving a lot, and if I'm in the field, it's impossible for me to do this. However, the weather has been so bad down here, it's been so windy and so wavy that we can't get out on the water. It's not safe. So on days like that, I'm at meetings and I'm at my desk. So on days like today, it's a perfect day to have a call.
Awesome.
Thank you for being with
Okay.
us.
Thank you so much, and we will be in touch with you. Have a good rest of your
I
night.
greatly, I'm glad that you invited me, and I know it was, but you originally contacted Rich Aaron's, and I don't know how you got his contact name, but he's one of my best friends. We've been working together for 35 years, and he knew that I was the person that you needed to talk to. So he immediately sent that email to me, and it worked out. So I'm glad.
Yeah, it was just a random Google search. We were really trying to find somebody, couldn't find anybody. So Christian and I sat down one day, and your name happened to be one that popped up, or your friend's name, sorry, Rich's name is the one that popped up, and
Rich Aaron,
that was that.
That's
Well, thank you
awesome.
very much.
That's great. Perfect.
Thank
You're
you.
welcome very much. And you guys have a great day.
Have a nice day.
You too,
Take care.
thank you. See ya.
Nice day.
I don't know.
Thank you very much.
Yeah,
Take care.
take care.
It is gone. Yep.